Good afternoon, ladies and gentlemen. It is a pleasure for us to be associated with CIA on a very important topic, which is water management for the city of Chennai. And we are part of this very interesting, exciting session, which is called Emerging Water Technologies. And with our experience with metering and monitoring solutions for the water industry, we are happy to be given an opportunity like this, and we will review the subject transitioning from water innocence to water efficiency. What we will do a review this afternoon on what is the basis of our presentation. Then, in terms of water management, there are various considerations when you are trying to manage the available water resources efficiently. First and foremost is the administrative consideration, and then how in modern times you can manage the infrastructure data, the digital information, and how that can help you to transform the way you operate and manage a water network. Then, what is a typical water network from a metering point of view? What are the metering concepts that we can look at? Technically, what are the challenges that we would face? What are the solution options? How do you select the right technology for metering, whether it's clean water or wastewater? Then how to cost effectively implement your projects. Water projects management is very, very critical, particularly vis-a-vis metering. Because in any normal water project, metering comes right at the very end with the odd meter here and there. That's not what the nation requires now. That's not what Chennai water management requires now. What is needed is extensive, planned, well installed and well managed water system. So we hope to give some key insights into not only the metering instruments, but also the computerized management practices in this regard. Then we will wrap it up in the end. Of course, let's begin with the thought that efficient metering will certainly lead to superior management of the water network. First of all, the basis of our presentation. We are having projects in the city of Mumbai, and we have lots of lessons learned from the ground, and also in the city of Thrissur, where we are working to provide metering and NRW accounting solutions. And so we have worked under many Amrit projects for studies, water audit jobs for consultants like Quick. So lots of experience of having measured water here. And we also have our technology partner News from Germany, who bring about more than half a century of manufacturing instruments for the water industry and implementing projects. So, and of course our own team with many decades of experience inside and outside India, executing water management, monitoring projects, SCADA solutions, etc. So with this wealth of experience, we are reviewing the monitoring and management and NRW reduction needs in our country in general, specifically in Chennai. And let's see what we need to take care of. In our country, generally we find that nearly half of the water is lost, and we call it non-revenue water. And that generally is not very sustainable for any water network. And municipal water systems are working very hard, like Chennai in this case, working hard to find solutions, how to get more efficient, how to record the asset data efficiently. For example, pipes were laid more than perhaps 70 years to 100 years back in many cases. Chennai might well be more than a 100-year-old network. Now, the information about the assets, the below ground pipelines or the above ground assets, would be lost with time as people change. And this needs to be recouped. That is possible with GPR, ground penetrating radar studies, and geographical information systems for above ground systems. So with that, you can bring all the asset data into an electronic platform from where the information can remain independent of the associated people. So we think that's a very important step towards improving efficiency in our water system. Because if there's a breakage in pipe, for instance, we don't know where to isolate. We don't know where the network is, where the pipe is below ground. It leads to a lot of problems and time lost in taking corrective action. Hence, such recording of asset data becomes very important. Another very important consideration, we believe, is the rehabilitation budget. In India, for any infrastructure work, typically there is a budget cycle of 15 years or so or plus. If we are providing metering equipment today, it means that we have to provide equipment that will last the length of time. And we got to install it in such a way that it will give you the benefit of the service of the instrument for that kind of length of time. Now, if that doesn't happen, then you will have a period of setback where the equipment does not meet the intended purpose because either the quality is not there or the installation is incorrect. Then we lose data again and we go back in the cycle of being unaccounted in our watering practices. Now, this is a very unique opportunity we have, ladies and gentlemen, to account for water. When we improve our old infrastructure, make it current, make it up to date, remove the leaks from the system, remove the unaccounted water, then this is the opportunity to do the metering right and get it working correctly. Benchmark the present condition. Now, many projects are being undertaken in terms of water management. You need to understand where you are beginning from. If a project happens where, crores of rupees are being spent, hundreds of crores being spent on improving the infrastructure, what is the improvement it is giving on the water management? How much water have you saved? Because when we talk about 24/7 water supply, clearly the water availability is limited from the source. So you have to manage it better to make it available for more people for longer duration. Hence, any project, it is always better to do a benchmarking with portable metering equipment. Now, the next important point that we would like to stress on is when it comes to metering, a lot of money is being spent on infrastructure chambers, for example, metering chambers. These metering chambers are abodes for reptiles often, and they are very seldom found to be useful from a metering point of view. So it is, for want of other word, I would say it is dead infrastructure investment. So it's better wherever possible to eliminate the chamber cost. We'll have a look later about how much it costs in as a percentage of a project metering project cost in terms of the chambering and civil works. Now, the final point here from an administrative point of view is consumer metering. Many towns have got simple mechanical single jet or multi jet meters to meter the consumer connection points. Now, without having to upgrade all the old meters, it is possible to record data digitally from these meters using the point of sale devices. We will go through that in detail. So the point of sale device with a billing application can bring every billing cycle, it can bring the revenue data into a system from where you can directly compare the revenue water that you have against the volumes of water that you are taking in bulk and then distributing in the network. So you can arrive at the losses at different areas of your city and with good precision, with appropriate selection of the metering equipment. So these are all the considerations in terms of administratively managing the water network. Now, digital transformation, as we said earlier, we believe that it is important for you to know where your assets are. Where is the water flowing exactly below your roads or within your city? Where is the record of this information? Now, a GPR study with a ground penetrating radar will help you to determine where the pipes are, and all the way into, nearly to your consumer connection. It can locate where your below ground assets are, and then a GIS study can bring you all the above ground assets very, very accurately. So your metering and distribution to the consumer, any overhead tanks and other infrastructure that you have, everything can be recorded digitally accurately. And once that is recorded, this can all be saved as AutoCAD files, for example, DWG files. And with modern systems, with open protocols and everything, it is very possible that if you are using a SCADA system for visualization, then this entire water network data that comes from the metering can be directly usurped into the SCADA domain. And that means that the information is not only stored digitally permanently, but it is also available for the operator. If there is a broken pipe somewhere, he is able to see exactly where the problem is, and he is able to locate before excavation itself. He knows where his pipe is and what he needs to do to repair. So this is modern management of the water network. This is an example of what a GPR study can bring about, where you can have your network and the branches of the pipeline, including the consumer connections, visible. And then you can pinpoint your meters exactly. You can put the metering equipment where it matters. How to put the meters, we will come to in a bit. But broadly, with a proper record of where your network is, your metering can be optimal and as required for the city, not randomly based on available or not available information. In a water network, we look at the intake system and then a treatment plant, and then there is the bulk transmission line, which takes water to the overhead tanks, or as the case may be, in a pumped system to a pumping station, which in turn feeds to the bulk feeder lines, and ultimately to the local distribution lines, which are, typically they could be 75 mm, 100 mm dia local distribution lines that are happening. The reason we are mentioning it here is that you could be carefully metering at each one of this point and then assessing your losses at each and every stage, from bulk transmission to the feeder lines across the overhead tanks, how much water you are losing. And then from the feeder lines into the local distribution system, from the metering in the local network against the bulk water metering, you can say, okay, what is my feeder line losses? And then, of course, you can compare the distribution line data with the revenue water records that you generate from the housing individual consumer meters. So like this, you can localize your consumption patterns and your losses from the network and capture that information very accurately and take remedial action where you require it, where your priorities are. That's important for efficient water management. Let's take a look at the concept then. Bulk water transmission lines. All the water that comes into the OHTs, all takeoffs and inlets, it's good to be metering them. How much water, what is the volumes of water we are taking in? And is there any deficiency in the supply lines? By looking at the velocity in the supply line, or sometimes there are blockages due to age in the supply line. These can be identified by metering in the bulk transmission line. And then, of course, just downstream of the overhead tanks or pump stations, as the case may be, you have the feeder lines, which are perhaps typically in a city, they could be 3, 4, 500, 700 dia lines within the city to specific areas. And by measuring in these, you can see how the water that is received in bulk is getting distributed to different parts of your city. And this metering also, remember, it helps you to detect abnormal conditions, such as if there's a broken pipe and you have a higher flow velocity through the meter, that can be a warning that there is potentially a damage to the infrastructure in this area. So like this, your maintenance can become proactive. Now, going from the bulk feeder line, you have the local distribution networks, which could be 100, maybe 150 there, maybe 75 in some cases. Then you can have individual meters for each area, call it a DMA if you like, and that is how nowadays it's called a district metering area. We can use economical, cost-effective solutions for metering in these smaller line sizes and integrate all the data together. And further down, of course, downstream of the distribution networks is all your consumers, where the consumer metered data can be recorded either with smart meters, AMR meters, or uh, through POS, handheld point of sale devices, which can send data periodically as and when the meter reader takes the data, it can go into a billing application, which can give you report and analysis on the consumption pattern. And in the end, what you are looking to do is for accountability all the way from the source to the consumer, step by step, stage by stage. In each case, how much water is being consumed, in which area, what is the pattern, is there an increase in velocity, or are the losses increasing, what are the seasonal variations in my water consumption pattern. All of these can come out from the system by itself without you having to chase people and record the data manually. Now, let's look at some of the technical issue. Earlier, we looked at some of the administrative challenges. Now, having done metering in different pipeline conditions in our country, different places, and in Tamil Nadu particularly, we've done 28 towns where we have actually metered the water consumption as a sub-consultant for the Tamil Nadu Water Investment Company, TWIC. And generally what we find is if you have to install inline meters, there is difficulty in isolating the pipeline. Where do you isolate? Where's the nearest isolation valve? Does it hold? How do you cut the pipe and install the meter? Then, of course, there is no such thing as standardization in pipe material because the towns have expanded at their own pace. Chennai has grown at its own pace over the last century, perhaps. And then there are different pipe materials and different depths and different situations have come about in that. Now, there is old infrastructure, pipes with a great deal of corrosion, and there's a great deal of varying hydraulic conditions. Operating velocities vary. Here you see in the graph there, you can have very low velocity flows. This is from one of our projects where throughout 24 hours, you find that the network velocity is not exceeding more than 0.2 meter per second. Now, this is a big challenge because certain types of meters don't work at low velocities. So you got to have metering technology that can measure whatever the velocity flowing through the pipe is. So as we said, there are different pipe materials: asbestos, cement, MS, CI, Primo pipes. There's a wide variety of pipe material that you have to measure through. Remember that our networks were never designed for measurement. We have to adapt the system to incorporate metering. But it is very, very critical to do that, because complete replacement of the infrastructure might be a very, very long drawn process. What you want is you want the low hanging fruit. You want to record the condition early. So metering needs to be proceeded with and the data needs to be available at the earliest. Now, these are, we are going to look a bit more closely at ultrasonic metering today, and we are going to look at examples of how we have used ultrasonic meters here. You can find that it is non-intrusive. We are not going into the pipeline at all when you use clamp-on technology, and it can be easily installed on the pipe and wired up all very, very rapidly. And the sensors themselves can be buried. And that's an important advantage when it comes to clamp-on metering. And they give very good accuracy with ease of installation. And they are particularly relevant for smaller pipes, pipes which are 700, 800 or less diameter. This kind of clamp-on technology works like a dream. An improvement from the clamp-on technology is this is what we are doing in the city of Mumbai. It is the insertion technology, where you can insert the sensor from the periphery of the pipe. Now the images are from a calibration exercise that we did on the meter, and you find that the tip of the sensor is protruding into the pipeline, and the sensors send data as pairs. Now, what you are seeing here is 8 sensors, and they work in 4 pairs. And this is the configuration that we are doing for the city of Mumbai, as I said. And this gives excellent measurement accuracy, particularly in the bulk water system. And it gives the same accuracy at incredibly low velocities as well. So this is an excellent measurement methodology for the bulk water supply from the source and distribution, because you get to record the data very, very accurately in your water network, and throughout the year your consumptions can be tracked so very efficiently. Now, this is the insertion type flow meter ultrasonic transit time technology. Now, you can see an image of where we have done such an installation earlier. That's a project in Sri Lanka, actually. And one interesting thing for us to point out, this is a calibration certificate for our 4-path ultrasonic flow meter from the Fluid Control Research Institute in Palakkad, a central government agency. And you see the accuracy levels that we are able to achieve. It's going down to 0.2, 0.2 to 0.3%. And we tried from 0.1 meter per second, 0.18 meter per second, all the way up to 5 meter per second flow velocity. And that's a very, very wide range. And we are able to maintain the performance accuracy throughout that measurement range. What it does then, it makes your water accounting very, very accurate. And that is what the city of Mumbai has picked. We are very proud to be associated with the city of Mumbai. We are very happy that they've chosen, with the pulse of the country in mind, to go for very, very high accuracy and very robust, rugged, typically German technology meters for the project. And we are very happy that we'll be serving one of the prime cities in our country with accurate data on how much water the city is consuming and how much they might be losing. Now, there are also sensor, there's the sensor technology options nowadays are absolutely many. You can put sensors inside the pipe also. When you are taking water from the dam at the source, we've done measurements in pipelines up to 6 meters diameter in hydroelectric power stations in Gujarat. We got measurement in a pipe that is 6 meters diameter. The sensor itself sits inside the pipe and gives the data. And you see a close-up there of the type of sensor that is used for this kind of measurement. Measurements are possible. As also are possible water measurements in open canals, because a lot of water is sent. Perhaps half of our water is used for irrigation purposes, and it goes out through canal systems. On the left hand side here, you see a radar type flow meter. which measures very accurately the water volumes that are sent through the canal. And there is also another technology which is cross correlation technology. In both cases, what we measure is the velocity of flow and the height to which the water is flowing, and then the instrument computes the volume flow very accurately. And this can be used for water treatment plant, where you have open channels just downstream of the sand filtration units. And this can also be effectively deployed in the wastewater collection system. Of course, bearing in mind that wastewater as well is a precious resource now, because for many industrial purposes, etc., wastewater can be treated and reused, and that's a uh, serious support for the stressed water systems in and around Chennai. Now, here is a very interesting concept that we need to look at. In a normal metering project, first of all, you have to survey the site and see where you want to put the meters, then record your location. Then you go through a construction phase. And then in the end, you get the metering. Now the world needs to be smarter. You cannot wait longer and longer to get the result. And year after year, you cannot be facing the same problems again and again, managing to keep the people with water. Nowadays, the metering can almost follow the survey directly with the clamp on technology and all that is available, battery powered devices, etc. Lots of options are available regardless of your site condition, that various different types of pipes, whatever it may be. The smart approach is that the metering work, which normally would happen a year or so, 10 months into a project, can actually begin well within 2 to 3 months of commencement of a project. So you could be actually reading the metering data in the 8th month of a project complete, as opposed to waiting for another 5 months, 6 months for the data to be available. And of course, metering cost, by selecting the right kind of technology that needs a lot less hardware, technology that's a lot smarter, then you can see that the cost also would go down in the smart approach as opposed to the conventional approach. Of course, there is this aspect that there's something that we are used to in half a century or more of measurement in water, and that needs to change. But then any progress is possible only when we are willing to adopt technology and make that change and make our approach a lot smarter. Now, in terms of costs, this will be something for the managers of water projects. We find primarily there are two technologies that are serving the water industry. One is the electromagnetic flow meter, and the other is ultrasonic flow meter. Each one has got its own domain. What we see here, for smaller pipes on the left hand side, you will see 50 mm to 600 mm diameter. You have in smaller sizes, electromagnetic flow meter has got its advantage. It is economical and it's very robust and reliable and works long term, so long as you ensure that there is minimum flow velocity in the pipeline, which is 0.5 meter per second. It will work well. Now, of course, as the size increases, you go above 500, 600, 700, and then in this case, we are looking at up to 600 dia on the graph there. The cost of the electromagnetic flow meter increases dramatically. And the construction time, which again is a reflection of the cost, and it is a reflection of availability of data. You will see here that too increases dramatically in electromagnetic flow meters as the time goes further. And on larger pipelines, even up to, we have taken here for comparison up to 1.5 meters pipeline. And you find that ultrasonic meters are consistently not only viable but better, more accurate in terms of data in all cases. So even the cost is significantly lower per meter, and also the time taken is much less. Thereby, the smartness is that you have the data available, as we saw in the previous slide, the data available at a much earlier stage in the project. A little bit of the wastewater technology as well, because this is something that Chennai has been grappling with over the years, that how to quantify, treat, improve our wastewater systems. Now, on the left-hand side, the image you see is that of an inserted meter in a pipeline that is in Perungudi, actually. It's particularly so close to Chennai for Pallavaram Corporation. That's measuring the inlet flow to a wastewater treatment plant there. So, what we want to show is you can measure in a very simple way in a pipe. You can also measure wastewater coming through a sewer system, as you can see here. This is from our project in the city of Patiala. And you can measure in open drainage channels as well. You see on the right hand side, that was done for Sidutuli in Coimbatore. And what you will find, ladies and gentlemen, you will find that the data is quite shocking. The flows of wastewater often are totally underestimated based on the potable water supplies and things like that. What people perhaps discount is the availability of groundwater or alternative sources of water that are used and sent into the drainage, from cleaning, etc. So if you count per the number of people there, the record is not accurate. If you don't consider the rainfall and open channel data collections, the ponds, etc., then again the data suffers. And if you don't consider the use of alternative source of water, that's a big problem. And hence, broadly, there is a tendency to underestimate the volumes of wastewater that are being generated. We can actually measure it. No need to guess at all. No need to use engineering practices to determine how much wastewater is being generated. We did a study entirely for the city of Patiala, where each and every drainage point, like the picture you see right in the middle, each and every drainage point was measured, and the discharges into what they call Choti Nadi and Badi Nadi. And then the whole wastewater consumption was accurately recorded, and so that they could plan for the wastewater treatment based on actual data, not on theoretical calculations. And why is it important? It is very important because wastewater is a precious reusable resource. Now we talked about the civil works, the construction of chambers, etc., in a metering system. And what we have observed in our market, in our country here, that typically there is 15 to 20% of the metering cost. So if you have a 100 crore metering project, then perhaps 15 to 20 crore is going for civil works, chamber construction, etc. Particularly difficult and expensive and space intensive for large pipes. Complicated. Now you can have a clamp-on metering system. This is a clamp-on metering system that we have installed, which can save 30 to 40% of your project time, because you can see the installation is very simple. You install the sensor and then close off with a conduit and fill it with foam, and then you can backfill the installation with sand, so that anytime in future, after year or two maybe, that you want to open and you want to calibrate the instrument for some reason, it's a matter of just removing the sand and gaining access. No need to construct chambers, no need to offer these accommodations for the reptiles and so forth that are around the area. So this is something that we want to draw your very careful attention to. Please use it carefully and don't put a lot of money in construction of civil works where they matter, metering where it matters. Thank you. Now here is a visualization of how we are inserting the sensors for the city of Mumbai, where actually the sensors are marked on the pipeline, and then we weld a nozzle and a ball valve there, and then pressure insert the sensor, hot tap it through the pipeline. So this whole metering happens quite amazingly without disrupting the flow at all. No one knows what is happening, just that the municipality has now started receiving the data of the metering. So this is what is possible when you have to meter in your network without having to look for where is the shutdown isolation possibility. Am I supplying water to a hospital or something and it cannot be isolated at all? So how to manage the metering? Water metering projects have been unsuccessful because of the inability to shut down the system. Now, there's no need to worry about it. Mumbai, we are very happy that they are in the forefront and taking initiatives like this where they can measure very, very accurately, but without having the trouble of shutting down. See, this is how the sensor is pressure inserted into the pipeline. You see the image on the left hand side where by turning the handle slowly the sensor makes its way into the pipeline, and then when it reaches the end point the sensor is locked inside. You see on the right hand side there, the sensor is locked inside and the tool is removed. So the sensor stays in place until you have to remove it whenever. So this is all happening with the pipeline continuing to be in operation. Then we come a little bit into your visualization and analysis of data, because metering gives a lot of data. What is important is to convert the data into useful information, to analytics. How do I analyze and interpret the metered data from the system? Now you see in the example above, there is a major pipeline which is going around a circle. So you see that horizontal pipe, and then each and every takeoff from the main source is metered. So you know how much water is going to each area. And then from that, as small distribution pipes take off, they are metered as well with AMR meters. These are 100 dia generally, or thereabouts. They are all metered, and the record is sent to a SCADA system where you can analyze the data as you see down below in terms of trend. You can receive alarms on abnormal conditions, a pipeline has burst, or there is a communication failure, or an overhead tank is overflowing, or you can record the velocities in your system and make sure that the velocities are indicating that there is no blockages and things inside the pipeline. Very, very useful information for an experienced operator. So this is how modern water management systems can be built, from GPR study into obtaining the pipe data and then locating the meter very, very strategically, carefully within the network, and then taking and analyzing the data systematically and providing you with not data but information. Now, how to bring the data into information? Now, you can have reports in the bulk transmission, daily, monthly, yearly consumption patterns, the distribution system, local distribution, periodic daily, monthly analysis, graphical presentation of this, comparison of previous week's data with current week, comparison of previous month's data with the current month, comparison of different areas of water consumption to the point of making it, per capita consumption. How much is the per capita consumption in one DMA or a ward or whatever you call it? What is the revenue water from the billing application with the POS device, as we looked at earlier, and we'll show some more details of that. You can obtain the what is the revenue water from the software, and then that can be directly compared with how much water is distributed. If 10 liters are distributed and 5 liters have been converted into the revenue, obviously the losses there are accounted to be 5 liters. And then of course you also get information about outage. If a meter is not having any flow and there's no water going through, then that is suggestive of an outage. And these kind of analytics come into play. This is what uh, we are providing in modern water management system. Revenue tracking, this is by use of a billing software application. And you see on the right hand side a POS, point of sale device, which is taking data from each and every consumer manually. Somebody goes and reads the meter and enters the data by hand with the consumer number, and then this data gets stored in a billing application server, and then the system analyzes the data and gives you area wise quantification of the consumed water, whether the bills have been generated. And you could go further and say how much of the bill has been converted into revenue as well, where the payment has been made. But anyhow, from a water management point of view, what is important is each and every consumer's consumption is analyzed, it is recorded, and it is presented to you as a quantification area wise. So in summary, ladies and gentlemen, thanking you very much for your time. To conclude our discussion, what we are proposing for the city of Chennai, and indeed for every municipality, every city in our country which needs to go from water innocence to water excellence, what we are proposing is that not to depend only on one technology, but go for cost effective solutions. Go for proven sensor technology. Don't just, there are many options available in the market. Go for something that's well proven, that will last the lifetime that you are looking for, and do things in a scalable way, so that what you are practicing in one part of the city can, for example, the Chennai Smart City, what is being practiced there, it can scale up into much wider city-wide concepts later. Now, the measurement solutions need to be perfectly optimized with information of the network data, and that considerably reduces the project cost and improves the payback period. Now, these are all based on water industry best practices, in terms of deployment of meters, as well as the technology SCADA solutions, completely web-based monitoring, where you don't need a control room nowadays. Your mobile phone can be your control room, and you can watch everything that is happening in the network, what is the consumption, everything can be available online, and even to the extent of how much revenue has it generated in the last billing cycle. Now, also the key performance indicators for operational efficiency. And as and when we outsource more and more, these KPIs become very critical, because when you give government assets to a contractor, how is he managing it? Is there efficiency? Is the water consumption being managed optimally? It should serve as a tool for you to evaluate performance, whether it's your own performance or that of a contractor. The key performance indicators should be orientated to improving the management practices. So the seeds of the flowers, we would like to say, are the flowers of the seeds of today are the flowers of tomorrow. Thank you very much, ladies and gentlemen. It's been a pleasure. Uh, we look forward to genuine improvements in Chennai, and I'm sure that with the leadership of CII and the government leaders who are taking water monitoring and management and so seriously, such improvements will definitely happen. Thank you very much. Have a good day. If you have any questions, we are ready to take them.